let's talk about batteries. So batteries and electrical storage are becoming bigger and bigger things in the utility industry. Yeah, review followed by a prayer. That's a good idea. So a little bit of the basics about batteries. Typically, they're chemical in nature, so they're storing electrical energy through some chemical composition. And the current, when they discharge, is caused by a change in the chemical composition of the electrolyte and of the plates. There's two different kinds of cells. There's a primary cell, which is destroyed in the process of furnishing the current. And then there's the secondary cell, which, although changed in the process of providing current, can be restored or recharged. So think of a car battery. A lead-acid battery would be a secondary cell. The little Duracell batteries you put in your flashlight, those are the primary cell type where they can't be recharged. Cell voltage is a function of the chemistry, of the internal resistance, and of the percent discharge. So cell voltage does drop as the battery discharges, as you know. Anyone who's left the lights on in their car would know that. And then cell capacity is the energy the cell can deliver before its terminal voltage falls to a specific level. And it's stated in coulombs or amp hours. They talk a lot about amp hours when they start talking about electrical storage. So an example, 100 amp hours over a 1, 5, or 8 hour period. Different lives. The battery is a combination of cells configured to provide a specific terminal voltage or capacity. So for example, somewhere in here I have, the lead-acid batteries produce about 2 volts per cell. So I don't know if anybody here recalls the 6-volt batteries, but they would have 3 cells. You could see them on the top of the batteries. So that's because they were taking 3 2-volt cells and putting them in series to give you a 6-volt battery. Here's a couple of different cell chemistries: galvanic or electrolytic. This talks about the electrochemistry and the exchange of anions and cations between the anode and the cathode of the battery, which is producing a current flow through the load. Now it's 12 volts. In the old days it was 6. But yeah, the 12-volt batteries are 6 2-volt cells connected in series. Let's take a look at an example. So the increasing the current withdrawn from a battery has what effect on the battery's capacity and why? So the battery's capacity drops as the discharge current increases due to the increased losses on the internal resistance and polarization of the electrodes. So the correct answer is D, a decreased capacity caused by increased polarization. Decreased capacity. Okay, a little bit more on the old primary cell versus the secondary cell type. And then there is a reserve cell where components are kept separate until required via activation. They're used for timing, temperature, and pressure sensitive applications and not typically reused. We were just going, Bruce, through the battery technology, the fact that there's a couple of different styles. There's a primary cell, which is not rechargeable, a secondary cell style, which is rechargeable, and then we've got kind of this reserve cell where it's kind of kept separate until the time at which it's needed. Other than that, not, just kind of marching down through this stuff. There's another example. A cell that undergoes a chemical reaction in such a manner that it cannot be recharged is called a, and the answer is a primary cell.